So today let's get started with the basic programming language C, starting with the topic storage classes. Storage class is an important topic of memory management in C, where most of us create many variables carelessly without even thinking how that's going to affect the memory. So the storage classes here comes to our rescue, which describes the features of all the variables which we usually create. And every variable that we declare in the C program has its own scope and lifetime. The attributes of the storage are listed here. Scope, which means accessibility in the program, lifetime, and the initial value. Please don't get confused between scope and lifetime, both are different. Some variables can be accessed only within the function block in which they are defined, and once the control comes out of the block, we can no longer access it. But the lifetime is different. The value of the variable exists either till the end of the program or till the function execution. Let's see more on this shortly with examples in some time. Now let us understand the memory layout. The first two, heap and stack, comes under the dynamic memory which gets accessed during the runtime. And the below ones, global and program segment, are the static memory areas which gets accessed during the compile time. All the variables which we usually create get stored in either of these. Let me give you a brief description on each one of this. Heap is a pool of memory which gets used during the runtime as per the memory need of the user. And stack, it grows dynamically as per the number of function calls. And coming to the static memory, it stores all the static and global variables created by the user in the entire program, and it allocates a fixed memory during the compile time. And coming to the program segment, it holds the instructions that are to be executed in the program during the compile time. Now let us look at the types of storage classes. There are 4 types: auto, register, static, and extern. Coming to the first one, auto. Auto is the default storage class for the variables, which are also called as local variables. From the name local, we can understand that the variables defined with auto are accessible only within the function block in which they are defined. So here we can see the lifetime and the scope is only within the block in which they are defined, and the initial value will be the garbage value if it is not initialized. Let us now look at the example of auto storage class. Here is the variable A, which is a local variable initialized with value 10. And as discussed, if there isn't any storage class specified here, it will be considered as an auto variable. Now coming to the main function, here we can see the test function is getting called and the control invokes here. Now post increment operation, the value of the variable A becomes 11 and the same gets printed here. Now when the control comes out of this function, the variable A no longer exists and we cannot access it. Hence the scope is only within the function and also its lifetime. Now again the same function is getting called for the second time, and we can see the value 10 is getting assigned to A, and again post increment operation, the value becomes 11 and the same gets printed here. Now let's run the program and check the output. We can see the value 11 getting printed twice. Coming to the second one, register. Register variables are similar to that of an auto variable, excepting that it gets stored in the CPU registers. The lifetime and the scope is within the block in which they are defined, and the initial value will be a garbage value if it is not initialized. As we all know, this is a computer architecture, and the variables which we usually create get stored in this RAM area of memory. Now let us consider an example which calculates the sum of n numbers. Here, the variables I and sum are stored in the RAM memory, and the addition operation takes place in the ALU unit of the CPU. And the compiler has to fetch the values of I and sum for every iteration. This ultimately increases the compile time, and hence the register storage class is used. Now the variable gets stored in the register inside the CPU, whose address can be accessed only by the CPU. This results in faster access of the variable stored in the register, ultimately reducing the compile time. Since the register address is known only to the CPU, we cannot access it. And even if we try to access it, it will throw an error. But keep in mind that we cannot store all the variables in the registers as the size is limited. And if there is no space in the registers, even if we declare it as a register variable, it will still get stored as an auto variable. This is an example of a register storage class, and as discussed, it is similar to the auto storage class. Please note that auto and register variables cannot be declared as global variables. It will throw an error. So this is a simple program to calculate sum for 10 times, and hence I have declared the variables I and sum as register variables, as these variables will be frequently used in all the iterations. Adding a value of 10 for 10 times will give a sum as 100. So now let's run the program and check the output. Here we can see the value 100 getting printed. The third one, static variables. Static variables are initialized inside the static memory during the compile time of the program, and these variables are independent of the function called stack. That's the reason why static variables exist even after the control comes out of the function. Now the lifetime is till the end of the program, whereas the scope is only within the block in which they are defined unless and until it is declared as a global static variable, and the initial value will be 0 if it is not initialized. This is an example of static storage class. The test function is getting called here, and here we can see the variable b is declared as a static int variable. Post increment operation, the value of b becomes 11 and the same gets printed here. As discussed, the lifetime of the variable is throughout the program. The variable b still holds 11 even after the execution of this function. And when the function gets called again for the second time here, this line gets ignored as the initialization of the static variable is already done. And now the variable b holds the value 11, and post increment operation, this value becomes 12 and the same gets printed here. Now let's run the program and check the output. Here we can see the value 11 and 12 getting printed. Coming to the last one, extern. Extern storage class is generally used to refer to the global variables that can be accessed by all the files. Putting it in simple words, we just tell the compiler that the extern variable is defined elsewhere in some other file, and we are just asking it to fetch that value. These variables are useless if we are trying to use it in the same file. They are mainly used to use the same variable that is present in another file. We should also keep in mind that we cannot initialize an extern variable, and also the variable which we declare as an extern should be a global variable in another file. Otherwise, it will throw a linker error. The lifetime of an extern variable is till the end of the program, and the initial value will be 0 if it is not initialized, and coming to scope, it is of global. For a better understanding, let us consider there are two files in a project, file 1 and file 2. In file 1, we can see here a is a global variable whose definition is in the main function, and here we can find a test function with the keyword extern, which means we are telling the compiler that its definition is present in another file. And in file 2, here we can see the variable a with the keyword extern, which is a global variable in file 1. And here we can find the definition of the test function. So coming to the main function, here the test function is getting called, so the control invokes here, and here we are trying to print the value of a, which is again fetched from file 1. So the output will be 2. Now this is an example of a global variable where the variable c is declared at the start of the program before the main function, and it is initialized to value 5, and the same gets printed here. Now let's run the program and check the output. Here we can see the value 5 getting printed. This is a program to understand the initial values of all the storage classes. Let us move to the main function. Here the test function is getting called. Here we can see the variable a is an auto variable. As we all know, the initial value of an auto variable will be a garbage value, and the same gets printed. Here we can see the value 10 getting assigned to variable a, and post increment it will become 11. And the test function is getting called for the second time again. Since the program did not get terminated, the variable a will still hold the value 11. And since 10 is getting assigned here, again post increment, it will become 11. Now here the test2 function is getting called. Here we can see the variable b is a static int variable, and the initial value of a static variable will be 0. And the 10 value is getting assigned here, and post increment it will become 11. and the test2 function is getting called for the second time again. Please do remember, if b is defined at the time of declaration, then this line will get ignored, but this is not the case here. B will still hold the value 11, and since it's getting assigned to value 10 here, it will again become 11 here post increment. And test3 function is getting called. Here we can see the register variables sum and I, and as we know, the register variables hold a garbage value. Adding a value 10 to the garbage value for 10 times will again give a garbage value. And coming to C, which is a global variable, so initially it will print 0, and we are assigning 5 to C, and here it will print 5. So let's run the program and check the output. So here we can see A as the garbage value, and next it will print 11. Here there's 11, and here when the function gets called for the second time, it is 11 and 11 here. You can see 11 and 11 here, and B holds initially 0, and 11 here, and when the function gets called for the second time, it will print 11 and 11. Here you can see 11 and 11, and the register sum gives the garbage value, and we can see the garbage value here. And coming to the value C, the 0 and 5, same as here. Now this is a program to show the common mistakes which most of us do unknowingly. I'm using the same program, just trying to access some variables out of the function block. As now we understand that the auto, static and register variables cannot be accessed out of the function block, it is defined. So here we can see we are trying to print the value of A, which is an auto variable in this function. We are trying to print B, which is the static variable in this function. And here we are trying to access the register variable I out of the function block, and we are trying to print the same here. Now let us run the program and check the output. And these are the errors. In line number 22, it is telling that I is undeclared, since we are trying to access the variable I out of its function block. Let's see the other errors. It's the same. Variable A and variable B is undeclared. Here we are trying to access the variable A and B, which are auto and static respectively. We are trying to access them out of the function block. So these are the errors which we usually get if we try to access any variable out of its scope. Here's another program to show the error when we are trying to access the register variable address. As we all know, this can be accessed only by the CPU. Here I am trying to assign the address of the register variable I to the pointer variable, and I am trying to print the same here. Now let us run the program and check the output. Here we can see that the error saying that we are trying to access the address of the register variable I. So this is not possible. This is the end of this video. If you like the video, please do like, share and subscribe. Thank you.